This is the brief on intensive and extensive thermodynamic properties. Now, these concepts are, well, they're absolutely fundamental if you're trying to understand how physical systems scale. They define which properties actually depend on a system's size and which ones don't. Okay, so first up, what's the fundamental difference here? Well, intensive properties, think temperature, pressure, density, they're independent of the system's size. They're just fixed characteristics of whatever you're looking at. But extensive properties, like mass and total heat capacity, they're totally different. They're additive. They scale right along with the size of the system. A great example is just the air in a room. A tiny little cube of it has the exact same density as all the air in the room, but its total mass, yeah, that's going to be way, way different. Second, there's a really essential mathematical relationship between the two. See, you can actually calculate an extensive property by integrating its specific intensive counterpart across the whole system. For example, the total heat capacity is found by integrating the specific heat capacity over the mass. And finally, we've got the empirical validation. We can actually see this in action. When a system's volume gets bigger, those intensive properties, like density, they stay completely constant, no change at all. Meanwhile, the extensive ones, mass and total heat capacity, are confirmed to increase linearly, in direct proportion to the volume. It's a perfect match, and it really validates that underlying math. So, the definition of any system property really just hinges on whether it's a fixed characteristic or if it scales right along with the system size.